Hello and welcome to another video. This is Cracking the Cryptic app Fog of War pack puzzle number 28, Croissant. This is a really beautiful puzzle, and the inferences that we have to use to ultimately solve it are going to be quite unique and really beautiful. I hope you guys enjoyed this video as much as I enjoyed solving this puzzle for the first time. Let's begin. The rules are Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column, and box must have all numbers from 1 to 9 exactly once. Sandwich. The numbers outside each row and column correspond to the sum of numbers between 1 and 9 in that row or column. And so, since we have number 35 right in this column, that means that the digits between 1 and 9 in this column sum up to 35. Let's begin by quickly selecting every cell in the grid and filling it with all the possible values that these cells could take. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is going to help us out a lot. So we're going to just quickly remove the number 1 from the notes where we know that number 1 can't show up. And now take a look at this row. It says 0. So the sum of numbers between 1 and 9 in this row is 0. Therefore, the 9 and 1 have to be right next to each other. So either this is the 9 or this is the 9. However, in this column, it's the same thing. The 1 and the 9 must be right next to each other. So since we, for example, let's assume that number 9 in this column is right here, right? If it was right there, since the 1 and the 9 in this column are right next to each other, then this would have to be the number 1, or this would have to be the number 1. But both options don't work because in this box, we see where the number 1 is. It's right here in the center. Therefore, this cannot be the number 9, and so number 9 has to go on the left side of the number 1. And that reveals something new, namely, it reveals a number 5 that we have to manually clean from the notes. Okay. What else can we do? Well, over here we know that these numbers sum up to 35, and there's exactly 7 of them. They're numbers from 2 to 8. That means that the 1 and 9 are on, oops, does that work? I guess it doesn't. This all only works when I click on a single cell. Right? No, it just refuses to work. Okay, I guess I'll just edit it manually. So this is a 1, 9, and then down here we also have a 1, 9. So nowhere in between can you have a 1 or the 9. Now, furthermore, let's take a look at this column right here. The values between 1 and 9 sum up to 4, and the only way you can have the 4, because 1 isn't included in the sum, you can't have 1 plus 3, it's just the number 4, so it is necessarily just one cell long. So there's 1 or 9, then there's the number 4, and then there's another 1 or 9. So number 4 cannot show up at the top because it must be between the 1 and 9. And it cannot show up as the last cell in that column for the same reason. Now, furthermore, this cannot be a 1 or a 9, because if it was, then this would be a number 4, and then over here you would have the 1 or the 9. So 1 and 9 would be in these positions respectively, and we know that this cell is in this box either a 1 or a 9. So therefore, this is not the 1, 9. Same thing down here because of this cell. So this cannot be a 1 or a 9. All right, what else? So this cell cannot be a 1 or a 9 now, because if it was, if this was a 1 or a 9, then where would the 4 go? As we said, 4 can go here because this no longer can be a 1 or 9. And if this was the 4, then this would have to be a 1 or the 9. But it can't be, because 1 and 9 are not options in that row anymore. And so this is not a 1 or a 9. And the bottom side is symmetrical. So this can no longer be a 1 or a 9 because this and this cannot be a 1 or a 9. And so this, this is not a 1 or a 9. Okay, we're making some progress finally. What else can we do though? Well, let's take a look at this thing. So the cells that sum up to 9 in this column are at least 2 and at most 3 cells long. Let's assume that they are 3 cells long, so that we have a 1 or 9, and then we have 3 cells, and then we have a 1 or 9 again. Well, obviously, in the case that it is 3 cells long, this can't start from here. 1 or 9 cannot be here, here, or here. Why? Because if they did, in order to be 3 cells long, they would have to include this number 5, because they have to go downwards. But the 3 cell long only works in the case where the cells are 2, 3, and 4, not containing the 5. So this would not be a 1 or a 9. And this can be a 1 or 9, so this is the only other option. And if it goes upwards, it would contain the 5, so it has to go downwards. However, if this was 1 or 9, 1, 2, 3, where would the 9 go? Right? It would need another cell, and it doesn't have any more cells. Therefore, we conclude that the 2, 3, 4 scenario does not work. There are exactly 2 digits between 1 and 9 in this column. Let's assume first that this is the 1 or the 9. Well, if it was, then you would have 2 cells, and then this would have to be the 1 or the 9, but that's the number 5. So therefore, this cannot be the 1 or the 9. How about this? Well, if this was the 1 or the 9, then this would have to be a 4, this would be a 5, they would sum up to 9, and then this would have to be the 1 or the 9. But because of these 2 cells, this cannot be a 1 or a 9. So therefore, assumption leads to contradiction, and this cannot be a 1 or a 9. This does work though. If this was a 1 or a 9, this is 5, 4, and then this is a 1 or a 9. That would work. However, let's look downwards. If this was a 1 or a 9, it would have to go upwards, right? Because you can't fit 2 cells downwards. So these 2 cells would be summing up to 9, and then this would have to be a 1 or a 9. However, they can be a 1 or a 9. So therefore, this is not a 1 or a 9. Okay. How about this cell? Again, it would have to go upwards, and it cannot go downwards because if it contained these 2 cells, it would still need a boundary of a 1 or a 9 below it, and we just don't have that many cells. So therefore, it has to go upwards. So if this is a 1 or 9, these 2 cells sum up to 9, and then this has to be a 1 or a 9, but that's a 5. Therefore, that is not a 1 or a 9. Now take a look at this column in specific. Numbers 1 and 9 can only show up in these 3 cells. And if it starts from, and they span exactly 2 cells, right? So they span either here or here with 2, 7, 3, 6, or 4, 5. And in both scenarios, this cell right here is a part of that border. And since both this scenario and this scenario imply the same thing, they imply that this is a part of the border, then this cell has to be a 1 or a 9, no matter what, by elimination of disjunction. So let's just get rid of the coloring to not distract us. So now we actually know where this 14 starts from. These 2 cells cannot be a 1 or a 9 because the 14 is at least 2 cells long. And it could not possibly be here because it would just end immediately. So can it be 2 cells long though? No, because then this would have to be a 1 or a 9, and 1 and 9 in this box are right here. So it has to be at least 3 cells long, and at most it is 4 cells long, ending here. Okay. That is some good progress so far. Let's keep going. Let's see what we can do. So, where should we look next? Maybe the 5. Yeah, maybe the 5. So, the cells that sum up to 5 in this column are at least 1 and at most 2 cells long. So since we see where the 9 is, this can't possibly be the number 1. It's way too high. Can this be the 1? Yeah, because then you would have 2 cells. So for the same reason, this cannot be the number 1. Okay. Now let's take a look at this cell in specific. And let's take a look at the 25. So you'll see that the 25 is at least 4 cells long. Can it go to the left if it starts from here? If this is the number 1, well, obviously not, because this is just 3 cells. How about to the right? Well, if this was a 1, then 1, 2, 3, 4, and then this would have to be the 9. But this cannot be a 9, because in this row, 1 and 9 are already taken. Therefore, this cannot be the number 1. Let's take a look downwards. Let's take a look at this cell in specific. Can this be the number 1? Well, the 23 is also at least 4 cells long, so it cannot go to the left. It must therefore go to the right. But 1, 2, 3, 4, this would have to be the 9. But this also cannot be the 9 because of this 1, 9, 1, 9 in the last column. Therefore, this is not allowed to be the number 1. And now we know something new. We know that this 5 cannot be 2 cells long because 1 goes either directly here or directly here. And between the 1 and the 9, you have the number 5. But number 5 can't go here. Therefore, this cannot be 195. So 195 must be starting from here, 5 and 9. So this is a 5, and so this is the number 1. That reveals the number 7, which we will promptly just clear from the notes. Okay. And now number 5 is done. So we're going to look into just removing it, yeah, so that it doesn't distract us. Okay. Furthermore, look at this. We know that in this column, the 1 and the 9 are showing up right next to each other because the columns in between them, not the columns, sorry, the cells in between them sum up to 0. However, number 1 is not available here. That means that a number 9 cannot go anywhere here because a number 1 cannot show up next to it. And so 1 and 9 are up there. And because number 1 is somewhere here, the 9 also has to be there, and the 9 is therefore nowhere else in the same box. And so 1, 9 is somewhere here. Either like this, maybe this is 1 and 9, or this is 1 and 9. Both of those scenarios imply the same thing. The central cell in between is a 1 and 9. And so we've placed the next 1, 9. We can remove the 0 from here because we've used it for our reasoning. Same with the 35, we don't need it anymore. Let's just do some cleanup. Let's check the 25 now. So it is at least 4 cells long, and we know that this is one of its boundaries. So it cannot go to the right. So neither of these cells can be a 1 or a 9. It must go to the left. Let's check the minimal value. 1, 2, 3, 4. So it cannot be 5 cells long because then it would include this cell and the 1, 9 would not fit anywhere. So therefore it must be exactly 4 cells long, with this being the other 1, 9. All right. And the cells in between, since we only have one option, are 4, 6, 7, 8. So this cannot be a 2, a 3, or a 5. 4, 6, 7, 8. And so nowhere else in the same row can you have 4, 6, 7, or an 8, giving you 2, 5, 3, triple, 2, 3, 5. Perfect. So you can have those in the same box anywhere. Let's check what else we can do. So we've made use of the 25 and we actually don't need it anymore. Okay. So now we can actually reason about this row, about this column, because number 1 and 9. Okay, so this cell right here cannot be the number 9. Why? Because if this was a 9, where would the 4 go? Remember, the 4 is just immediately either here or here. And if it was here, this would not be the number 1. And if this was here, this would not be the number 1. Therefore, this cell is just not the number 9. So 1 and 9 can only go in these 3 cells. And if you remember, we already reasoned this way. Either this is the 149 or this is the 149. In both cases, this cell right here is a part of the border, meaning that it must be 19 by itself. So this is the 19. We can now remove the coloring. And now that does tell us a lot. It tells us exactly how big the 14 is. It cannot be 4 cells long, and it must contain the number 5. So it's either 257 or it is a 356. So we can remove the 8 from here. We can remove the 4. And 6 and 7 both work. 2 and 3 both work. Okay. Let's keep going. So this cannot be a 1 or a 9. All right. What else? Well, let's take a look at this 23. The 23 starts from here or from here, but the other 1 or 9, if it starts from here, are on the other side of the number 5. And same here, if it starts from here, right, and it has to, then the other digit, the 1 and 9, are on the other side of the number 5, meaning that it must contain the number 5. So we can remove all cases that don't contain the number 5. And now we're left with 3 cases. Let's first consider the case of 3578. Let's assume that this is a 3578. So if it is 4 cells long, it cannot start from here. Why? Because if this was a 1 or 9, then 1, 2, 3, 4, then 1 or 9 would have to be here, right? That doesn't work. So it would have to start from here, and it would have to end here. And then you would have 5, 7, and 8 in between. Sorry, 5 is already taken, so you would have 3, 7, 8. 3, 7, 8. So we're considering this case. Well, in that case, what would make the 14 work? Over here, you need to have either a 257 or a 356, but you can't have 257. This cannot be a 2 and 7 because 7 is already taken up there. And it cannot be a 356 because 3 is already taken up there. Therefore, that is a contradiction. And that configuration of the 23 does not work. It cannot be a 3, 7, 5, 8. Okay, let's try the bigger one. Let's try the 2, 3, 5, 6, 7. Now, in that case, it is 5 cells long, and we don't really know where it starts from. It could start from here, and then 1, 2, 3, 4, 5, it would end here, or it can do the other way around. It could start from here, 1, 2, 3, 4, 5, ending here. But in either case, number 5 is already here, and we're reasoning about these 3 digits in the middle. So the 3 digits in the middle could only be 2, 3, 6, or 7. And in fact, it has to be one of the configurations of 2, 3, 6, 7. Because if it starts from here, for example, it would be ending right here, right? And then, for example, this can be the number 2, and then this is 3, 6, 7, or this could be the 7, and then this is 2, 3, 6. So no matter where the 1 and 9 is, some configuration of 3 numbers between 2, 3, 6, and 7 would have to be here. Let's start with the first one. There's 4 in total. Let's start with the assumption that these 3 cells are in fact 2, 3, and 6. Well, if it's 2, 3, and 6, then obviously this cannot be a 2, 5, 7 or a 3, 5, 6, because you would not be having a 2 or a 3. So none of these would work. Let's assume instead that this is not 2, 3, 6, but that it is a 2, 3, 7 instead. Again, you don't have a 2 or a 3, so this cannot be a 2, 5, 7 or a 3, 5, 6. Okay, let's try with the 2, 6, 7 instead. Well, if you don't have a 2, 6, 7, because you don't have a 2 or a 7, this cannot be a 2, 5, 7, and it also cannot be a 3, 5, 6, because as we said, this is 2, 6, 7, you don't have a 6. The only other case we have is if this was 3, 6, 7. But in that case, you don't have a 3 and you don't have a 7. So because you don't have a 3, this cannot be 3, 5, 6. And because you don't have a 7, this cannot be a 2, 5, 7. So no matter the configuration, this case does not work and it cannot be 5 cells long. I apologize if this was a bit abstract, but there is no better way to really write it down. And so it must be exactly 4 cells long, and it can only work if the values are 4, 5, 6, 8. Now, since it is 4 cells long, it can't start from here, remember? Because 1, 2, 3, 4, it would have to end here. So that doesn't work. So it can't start from there. This cannot be a 1, 9. It starts from here. So this is a 1, 9. Now, 5 is already taken. So the digits in this middle box are 4, 6, and 8. Cannot be a 2, 3, or a 7. And now this is a 1, 9. Let's clean things up first. So over here, you cannot have a 1 or a 9 or a 4, 6, 8. And nowhere here in the center can you have a 4, 6, 8. Now look at the 14. You can no longer have a 3, 5, 6 here because 6 is somewhere up there. So therefore that case doesn't work and you need to have a 2, 5, 7. 7 can only go in this square, meaning that this is the 2 and so this is the 3. We've now solved the 14 so we can gray it out, and the 23 is already solved so we can gray it out. Okay. The 0 is also solved, we can gray it out. And now look at this, 1, 9, 1, 9. It's revealed the position of the 1 and the 9. So we know that number 4 in this column has to go in between them. So this is the number 4. And crucially, do remember how when we were reasoning about this column, this could be a 1 or 9. And then we said that this could be a 5, this could be a 4, and then this could be a 1, 9. Well, that is no longer possible, because if this is a 1, 9, then these are the borders of 1, 9, and because 5 is here, 4 would have to be here to make the 9, but 4 can no longer be there. Therefore, this cannot be the 1 or the 9. Now, that forces 1, 9, 1, 9 to be here, here. And since 5 isn't available, so let me just first put the 1, 9 down here. And since 5 is no longer available, then neither of these digits can be the 4, because the 4 would need the 5 to make the 9. And an 8 would also need a 1 to make the 9, which is not available. Okay. 6 would need the 3, 3 is available. Okay, this is more or less fine. So a number 8 was revealed when we placed the 4, so let's just manually clean the notes for it. Okay. Now 6, 7, 6, 7, that's a pair. So we are going to just quickly clean things up. 6, 7, okay. What else can we do? Let's go through the digits and see if maybe something simpler opened up before we continue. But we will eventually have to start reasoning about the 23. In fact, maybe we should do that immediately because the 23, as we said, is at least 4 cells long. And on the right side, this is the only place where it can go to. So this has to be either a 1 or a 9, because it can't just completely be contained within these 2 cells. That's impossible. So it starts from here. Let's assume that it is 4 cells long. 1, 2, 3, 4. Well, then this would have to be a 1 or 9, and it isn't. Therefore, it has to be 5 cells long. And then this is the 1, 9. And actually, in this box, we have a 1, 9 pair. So nowhere else can you have a 1 or a 9. Now, furthermore, number 7 is contained, so we know the exact case. This has to be the case 2, 3, 5, 6, 7. So you cannot have an 8, and you cannot have a 4 either. Okay. So on the sides, you cannot have 2, 3, 5, 6, or 7, giving you the number 4 right here. And so this is the number 8, revealing the number 3. So number 3 cannot be anywhere in the same box, column, or row. Let's keep going. Number 3 is either here or here, so it cannot be anywhere up there. All right. Let's go through the digits. So 1, 9, 1, 9, that's a pair. You cannot have a 1 or a 9 anywhere up there. This is an 8, revealing number 2 that we have to manually clean. Okay. What else? Okay, let's go number 3. And then 4, 5, okay, 7, 8, and lastly the 9. So 1, 9, 1, 9. So you can't have a 1 or a 9 between them. Okay. But we must have missed some stuff. I guess we should just go a bit more slowly. Okay, that's the 1. And this is the 2. Okay. Let's go for the 3. The 4. Actually, 1, 9, 1, 9. And 3 is no longer available, meaning that this cannot be a 6, because the 6 needs a 3 to make the 9. So this is a 2, 7. Okay, that was a bit tricky, wasn't it? So now that we've placed the 2, we should recheck. So So the 23 is also done. And the 7 has to go here, meaning that this is a 7, and so this is the 7. Now this has to be the 3, 6, 8, 5, and then this is 5, 3, 2, 6, 5, right over there, and then this is 5, 2, 3, and this reveals a 9 that we have to manually clean. Oh my god, that is not proper cleaning. Okay. And then this is the number 1, 9, and then 6. So this is 4, 1, 9, 9 and 2, and then 1, 4, 3. This is a 9, 1, and this is the 9. That reveals the number 4, which we have to clean manually, giving us a 1 and then a 4. Okay. So this is the number 3, giving us the number 6. So this is an 8, 8, 6, 2, 5, 6, 7, 2. It really all came crushing down, didn't it? 4, 6, 8, 4, 6, 9, 1, 7, 6, 8, 5, 2, 3, 7, and then 8, 4, 3, and 5, 9, 1. Wow, that was a very nice puzzle. I really enjoyed it, and I apologize for uploading this video pretty late. So you might have noticed that this video is not in order. I usually upload these videos in the same order that the puzzles are released in. However, I just entirely skipped it. I labeled the Tough Pill to Swallow video as the puzzle 28, which is false. This is the puzzle 28. That was the puzzle 29. And because I made that mistake, I just jumped over the puzzles and I just kept going. And now I have to rename the videos and just make sure that everything is in the right order. Thank you guys for watching, and see you in the next one.